Oh yeah, how's it going? Today we'll be talking about some specific rules. We're going to be doing the power rule, and then after the power rule, if we have time, I think I'll be able to do the product and the quotient rule. So first, the power rule. This is probably one of the most important ones. Maybe it is the most important rule for derivatives. You can like use it to like immediately find the derivative of a function, depending if that function has a variable with a power um, along with it. But here we have what the power rule is. So we have a function f of x is equal to x to power of n. X is any variable, and n would work. And this power rule works as long as n is not equal to 0. If it's 0, power rule does not work. Um, but yeah, so what the power rule states is if we have this function at the top here, this function right here, and it's not equal to 0, and it's not equal to 0, um, we can find the derivative, or f prime of x, which is the derivative of x. The derivative of x is going to be equal to nx to the power of n minus 1. So let's do an example. So let's do an example. So let's say f of x is equal to let's say x squared. F prime of x, according to the what's called power rule, is going to be 2x to the 2 minus 1 power, which is just going to be 2x, because x to the first power is just uh any number to the first power is just itself. Okay, so yeah, 2x. Let's do another example. This time, remember, n can be any number as long as it's not negative. So it can, as long as it's not 0. So let's do the power rule with a negative number. This gets a little bit more complicated, but remember, it's just an exponent, and negative, all it means is it's a 1 over 2 to that power. And that's all it is. So let's say g of x. Let's say this is equal to x to the negative third. And now, what's g prime of x? Oh man, let me just write all that. Oh, this is horrible. All right, that's all right. So g. Oh my gosh, sorry, having some difficulty here. All right, so g prime of x. It's going to be, so remember, we're bringing the exponent to the front. Negative 3x, and we're subtracting by 1, which means it's negative 3 minus 1, which makes this negative 4. If we want to simplify this further, this is the answer, like right here. Um, if we just want to simplify this further, we can just turn this into negative 3x fourth, because remember, negative 3, that's numerator, x to the negative 4 goes on the bottom, because negative 4 just means it's 1 over x to the fourth power. So it can be both. Let's do one more example. Well, you know what? That's good enough. This also works for like decimals, so let's just go ahead and do one decimal. Let's see. Let's, I don't know, 2.5 z prime of x. Remember, a function can be any variable. It could be b of x, whatever. And then that's just 2.5 minus 1, which is 1.5. That's is what it that's the z prime of x. So the power rule is extremely, it's in the name, it's extremely powerful. But let's move on into a little bit more in-depth look into the power rule. Um, so these are certain rules of the power rule, and I'm gonna change from f primes, or the function primes, to d over dx, just derivative. So these are like certain little rules within the power rule. So let's find the derivative of x to the 0 power is always going to be equal to 1. It's always going to be equal to 1. Or, well, not exactly. It's going to be equal to the derivative of 1. Because remember, any number to the 0 power is just 1. And so we simplify it down. And remember the derivative. Oh, well, it states that if you have a derivative of just a constant of a constant number, like 1 or 2 or 10, it has no variable, just a whole integer, just a number, it's going to be equal to 0. So if you have d over dx, and it's or, well, derivative of a constant, this a is a constant, this right there is a constant. Let me just not write that, but just know that a is just the constant. It's gonna take a little bit to write that. I can't really write too many long words. Um, just equal to 0. So next rule we have is the derivative of a times f of x. So this is just equal to, you take out the a, you basically take out the a, and then you find the derivative of f of x. That's what it ends up turning into. Oh, um, oh, it could also be written like this. It basically just simplifies into a times f prime, which you get at the end. Sorry about that. That's what it turns into. We can do an example. So, for example, the sorry, derivative of, let's do two. I don't know. Let's do uh, just any function. I don't know, x to the sixth. Remember, so we take out the constant. Well, not the constant, but the coefficient. I think that's the coefficient. We find the derivative of x to the sixth power. We isolate it, and this ends up just being 2. Remember, we're finding the derivative of x to the sixth power, so remember from the last video, this just ends up being times 6x fifths, which ends up being, sorry, my dog barking, so I had to go see what was going on. But anyway, you find the derivative of x to the sixth power, which is just 6x to the fifth power, and then remember, you bring the 6 to the front, so it's just 2 times 6 to the x. 2 times 6x to the fifth power, and ends up being 12x to the fifth. All right. Another rule: derivative of f of x plus g of x. So the derivative of the function of x plus the function of g of x. So this is just equal to the derivative. It's just like the property of limits. You find the derivative of each individual part. Which just ends up being f prime x. Let me write that. F prime x plus g prime x. I just didn't have enough space. If I had enough space, they'd be just in a straight line. That's not a power. That's just a parentheses that I drew too close. So f prime of x plus g prime of x after you find the derivatives. That's what that is. We can do an example of that. Let's just do it really quick. So we're finding the derivative of, I don't know, 2x8. That's not a really good example because we want to we just want to test this individual rule, not combine the others yet. But eventually you're going to use all of these in combination, in unison. and it's pretty cool. But anyway, let's just do x10 plus x5. F of x is the first one. Second one is g of x. I don't think I have enough time for the product and quotient rule, but it's fine. I'll just do this power rule in that video. So I'm just gonna skip this step up here, this one, but basically what I do is I'm just finding the individual derivatives of each function, and each function is on each side. So it ends up being 10x to the ninth plus, oh man, 5x to the fourth. Yep, that's what it ends up. That's what it ends up being. And that's basically all you need. At the end of the day, you use all of these like in unison, and it's pretty cool. So let me do an example of that. Let's just define a function of x. I don't know. Let's just do something crazy like 10x to the 10x squared plus 20x minus 100, just to make it look scary. But in reality, this is very very easy. I'm not gonna write it all out, but just know that the rules are above. I basically just followed all of these rules that I just made, so I'll just show them to you. Maybe you want to write down the notes for them or something. But I'm just going to do this really quickly. So remember 10x squared, we exclude the 10, and then we use the normal power rule. So we bring the 2 to the front, which is going to, and then which is going to end up with 2x, and then remember it's the exponent minus 1. So that's 2 minus 1, which is just x1, and we don't have to put that. That's just like a base. So it ends up being 10 times 2, which is, this just ends up being 20x. Remember, whenever we have x to the first power, it always ends up becoming, it basically just ends up becoming this. So we exclude 20, and then we get 1x 0, and any number to 0 is just 1. So this basically the whole thing just cancels out into 20, into whatever the coefficient is times 1. So that's just plus 20. And remember, whenever you let me just finish this 20. And remember, whenever you have a constant number like this one right here, that's constant. Remember, that's just 0. Those constant numbers are always just equal to 0, like this rule said right here. This is a constant number. So that answer just ends up being 20. The derivative of f of x is f prime of x, which is 20x plus just 20. That's about it. Thank you.